Welcome to another GCBASIC demonstration. This is about adding your own assembler to the IDE. This is called Hidden Gem. Pretty simple to do, but not explained, so I'm going to explain it. Uh, Let me just show you what I've got. I've got a, let me just fire this up. Just, there we go, just erase that chip. That's it, bulk erase, continue. What am I doing here? There we go, great. What I've got is a PIC-AS 2 low pin cat demo, 16F690, PIC-Kit 2 attached using PIC-Kit Plus. Doesn't really matter about the PIC-Kit Plus. You can use PIC-Kit. You can use old PIC-Kit, PIC-Kit 2, PIC-Kit 3, PIC-Kit 4, or 5. Doesn't matter. All we're going to do is flash some LEDs, but that's a resulting outcome, not what we're here for. Let's go back to the presentation. Right. What we're going to do is talk about how we support extending the tool chain, because we support PIC-ASM, GCASM internally, PIC-AS, AVS, AVRS. There's a special video on that, and there's others, and we're going to show you how to do others. And as the others appear, I'll add them into the support folder up on GCBASIC. Let's have a quick look at what we've got. I'm going to take you through today, adding GPASM. GPASM is a very small, compressed, compact assembler. Why you'd want to use it is for your own choices. I am not. It's a support. We support it. Why you want to use it is your own decision. Okay, let's have a quick look how it all works. So GCBASIC is an open source compiler for PICs, AVRs, LGTs, and we support many different assemblers. How does it go about doing that? I have to show you this diagram every time. You take your source, put a pen on here. You take your source code, you take some libraries that you're calling, could be your own libraries or the standard libraries. They get pre-processed, goes into a code translator where it's normalized and syntax checked. Goes to the internal assembler, assembles the code and generates files like an assembly file if it's needed, some text files and HTML files that you can read. Goes through the internal linker and then gets produced into a machine code. That's how it works. Using PIC-AS as an example, it's going to take it takes your source code, similar process. Takes your source code, takes some libraries, puts them into the preprocessor, sucks them all together into a code translator, assembles. But this time, the assembly file is produced, and there is no internal assembler used. It passes that out to the external tool, PIC-AS, MPLABIC, and in this case, I'm going to show you how to add in a new one called GPASM, and then it produces absolute machine code. And then you get different outputs and different things that you can have a look at. Okay, so let's go do that now. Straight into here. This is a demonstration, standard demonstration, reversible, and I'm just going to compile it up, and you can see it compile. Let me just zoom in for you. There you go. You can see it compile. Found the 690. It's compiled it. Let's have a look at what we got out on the camera. LEDs. But what we did, if we look in detail, what actually happened, we used PIC-AS, and PIC-AS is here, assembling using PIC-AS. And how do we select PIC-AS? Function key F4, edit preferences, up it comes. Compiler, and it's in this drop down here. But I've only got 4 in there. Look, I've got GCASM, that's inbuilt. I support that, so it's sort of built. You don't need any setup for that because it's PIC-AS, MPASM, and AVRASM. Well, there isn't a GPASM in here, and there's no tool variable in here to support it. So there's no point hunting around because it's not there. So how do we go about adding this in? Bit of a manual trick, but it works. So let's open up a file called USE.INI, and USE.INI is a file that's in your installation directory. It's inside GCBASIC and it's called USE.INI. And inside here, it's got a lot of parameters. Normally, they're managed by Press Editor, but today we're going to have a little hook and a little look around here because what I've added in here is GPASM. Now I've installed GPASM. It's up on SourceForge. You can get it, and I installed it to this directory: C:/program files, GPU tools, bin, GPASM. So if I open up my Explorer, there are the files there that are installed. Nothing fancy. You just need some command lines, and we're going to pass those command lines to it. And so I need an entry in here just to say that I'm going to be using GPS as my tool. And here are the parameters that are needed. The chip model, which is, and you'll find that throughout here, it's called, and it will get substituted for the chip you're using. I is ignore case. The file name is the one that is getting passed, the ASM file name. W2 is turn the warnings off. And -K is can't remember. Does something. Now that entry is in there, I can refer to it. So if I go back into the pref tool, function key F4, edit the preferences, and I just come into the compiler, I just type in GPASM, the same name of the tool. Don't think it's case sensitive, probably not. I'm going to say, okay, there is no validation of this, but it should do it for us. Press OK, great, back into my source program. I'm just going to go to the bottom of here so that you can see it. And then I'm going to say, make my hex. Look at that. Assembling the program using GPASM. Does it work? I'll program it. Press function key F5. Go out to the camera. It flashed as it's programming. Hey, got the same result. So what we've got is a method of changing and adding tools. You can add your own assembler in inside of USE.INI. Make sure you take a copy of this sort of configuration and put it somewhere else because it will get potentially overwritten if you do a complete reinstall. Okay, and this is where so don't go be changing anything else in here. That's quite clearly not wise. But in recap, you can create your own tools. It's an assembler. Give it a command location. You can do some very clever things with tool variables. I'm not covering that. You can work that out yourselves. And then the parameter that needs to be passed to it. So if I type in -M, I can remember this from years ago. File save. We'll see what it does. Look. Function key F6. And what we'll do is we'll have a look at it. And it's given me a memory map. So I can see in here the memory map. Look. So in here, that is the code it's written. I will take a copy of that location. I'm going to go into my PIC-KIT2 over here. I'm going to import, oh no, I'm not. I'm going to import the file I've just created, the hex file. And we should start to see the same sort of things in here, like 118A through to 1283. Oh, that's what we've got here. Look. If we go down to line, what's that? 5F, 242866. So we've got the same thing. So you can play with it. You can add your own switches in if you wish. I don't think that's a handy thing to have a dump like that because your programmer will validate things. And this is address 2000. Look, we all know what this is. Look, that's the config. Look, which you don't normally get to see. Config 3FD2. Now, why does that show up in here? That's because read as imported 3FD2. It hasn't been masked. Okay, when it's masked off by the programmer, it's the correct value. So you can now get some more information. But GPASM only supports old chips. And why would you use that? Is because maybe PIC-AS doesn't support it? I don't know. But I'm showing you a method of extending out the toolchain. We've extended the toolchain by adding in another capability. So, wanted to show you adding your own assembler, bit of a hidden gem. You have to manually edit the USE.INI file because I'm not going to be adding that one to the standard stock. Enjoy.